We'll give everyone a um, a few more minutes to come in, but before we get started, does anyone have any questions on, everyone should have received their final project proposal feedback. So does anyone have any questions on that or hopefully, well, like I said, everyone should have received that back. So if you didn't, definitely let me know.
Yeah, hey Charlie, I have a question. So in my project, I'm using a map, uh, and there is this administrative regions, let's say like boroughs, um, that I have to that I actually download from from this server, but but they happen to have these super weird coordinates. I think it's
Mhm.
like a it's a coordinate, but it's not like a longitude latitude, but it's called like a Sirgas. It's like another system. So I'm having a lot of. I'm gonna start having a lot of problems trying to translate that file
Mhm.
into WSG84, which is the latitude longitude
Yeah.
wants to use the to use something like Mapbox. So I was wondering if you have any suggestions on how to convert these uh, in GeoJSON files. Well, I download like uh,
Uh-huh.
ArcGIS Pro, but I don't know if it's gonna. Pro is probably a trial, so I don't know if it's gonna work. And also, yeah, I don't know how it's gonna be that translation. I thought about another solution, which is like going to one of these GeoJSON online editors and do the shapes myself, so and export it on on geographic coordinates. But I don't know if you can think of another approach that I can use. um,
Yeah, there's so I actually had to use something similar. And you were looking at it was the Colombian education data, I believe, right? Uh,
yeah, that's right.
yeah. The so actually for this here, this is just module 2 from GitHub, and I was using PyProj, which basically and this was something that sort of when I was first working with this data, I I found out, and I don't remember exactly, like I'm not remembering exactly how these are defined, but basically this this PyProj um, library would let you do your sort of your conversions on the fly like this. The I remember, and these sorts of things are tricky. Like I remember, this is actually converting from feet to meters because in a lot of, and I don't know if the system you're looking at is is the same as what's happening here, but for for the Pluto data, it was using like basically for regions. They're like for small enough regions where you're able to basically assume that the the Earth is flat and you have just pretty you're sort of just using squares basically. So if you were to try to do that across the whole world, you would run into issues because you know lines of longitude are like the distance between them changes, whereas with these like fixed coordinates, they don't. It's meant to be like I think they refer to it as a planar. Um, so I would. try to, and there's a site that, and I mean, at this point, I don't remember exactly what it was. But after this, I'll try to see if I could find it. But basically, with PyProj, you should be able to just look up like what the projection is, and it'll it's usually based on regions. So like they have like different regions across the U.S. there. I haven't looked internationally, but I imagine it's something similar there. So I'll see if I could try to find that site for you. But if you could like if you're finding a service that does that, then then PyProj would essentially be the library where you would be sort of making that conversion. Um,
Okay. Can you write in the chat the name of the library? It's a PyRoach. Sorry, just
oh
to
yeah,
make
let me
sure.
write it. So it's this right here, PyProj.
Got it. Thanks.
Yeah, cool. Cool. So let's get started here. So thank you all for coming the day before Thanksgiving. I actually, when I was first setting out the dates, I didn't realize this was cutting it so close to Thanksgiving, but so I ended up just sort of making this pretty light. We'll just be going over homework 5 and talk a bit more about sort of a few, sort of walk through some examples of interaction that you might want to include in your final projects. So with that, let's get going. So for homework 5, we had it was basically divided into 3 parts. So we had different, sort of a beginner, intermediate, and advanced. So the beginner was sort of working with simpler JavaScript functions. For the advanced, the goal was to, or for the intermediate, the goal was to sort of start using D3 for placing HTML elements. So not, getting to visualization just yet, but just, sort of using it to do things like build tables or display information and query information. And then for the advanced, that was building off of what we've done for module 4.5. So, using our, like sort of building your own app based on the examples that we went through 2 weeks ago, and sort of use that trees endpoint, the API, the trees API, to sort of build your own Flask API on top of that, and then sort of build build something based off of that. And again, that part was a bit more open-ended. So we'll just start with the sort of more straightforward questions here. So these were really similar to the what we were talking about 2 weeks ago, like just sort of the more intro JavaScript stuff that we were going through. So here, this is just reversing any word that's being typed in. So doing something like that. And the, hold on 1 second. There I am. So here, here basically is where this is being done. So you'll notice this a lot. Like we have just empty divs where we're sort of sending we're using as sort of our answer targets, and we're just simply using JavaScript within these script tags. So for the first two parts of homework 5, we have everything within this HTML. So simply enough, you could see what we're doing. We have sort of a function that is reversing strings. So again, because it's JavaScript, like we have to do things pretty manually. So we have this reverse string. We have a helper function which lets us write to DOM. So we have the sort of whatever target we're looking at, and we're just defining the inner what's called the inner HTML, which as we mentioned before, that's just a way to sort of populate the inside of a target div. And then just having this doc submit function. And for this question, we're using sort of this form-based input. So we're just defining our form up here, and we're referencing this doc submit just in the onClick attribute here. So we have sort of our form corresponding there. This is what we're looking at, and it just lets us sort of reverse anything that we have there. So for question 2, this is just sort of still similar to question 1, where it's taking single input. Yes.
Sorry, Charlie. Are you? I mean, I'm only seeing like the HTML file. Are you exploring the code, or is that or you're just talking on that page?
Okay. Yeah. Hit play. Yeah. Sorry about that. Thank you for letting me know. So yeah, I was just going back and forth between this page here. So doing doing something like this, showing the reverse text. And what I was pointing out before was this was the empty targets here, which I think was really the only thing that sort of didn't make sense there. Otherwise, with these functions, we are pretty manually going through a string and reversing it, and just simply having this function doc submit, which is tied to the onClick attribute here. So that's question 1. And then for question 2, it's very similar in nature. It's just taking in a single input, and in this case, it's just making a more complex HTML object. So in this case, it's making a table. So this is showing off just how you're able to essentially build these more complex elements just by using things like for loop. So you could see here I'm just sort of looping through the number of elements. I'm sort of keeping track of my number of columns, and just adding adding these TRs, TDs. So let's see what that looks like once we make it. So we have our table created, and I'm just going to inspect the elements here, and you should be able to see this is sort of all of the HTML elements that we're looking at here. And we're just sort of using this this for loop to, really sort of loop through all of our elements and create our multiplication table. So we, sort of have this function here where we're making our multiples. We're referencing that over here, so you can see we're using this table make multiples, and then that's sort of how we're passing everything down the line. So any questions there before I move on to the intermediate stuff? One thing that you could actually do just to sort of see what comes out there, if I refresh this, go to my console here, make my table, and you'll see, it's pretty much it pretty much just created the table, as one long string. So all we're doing is just, inserting that string into the DOM. So any questions there? Cool. So let's move on to the intermediate part. So in the intermediate part, while we're not doing sort of visualizations with D3 just yet, we're using D3 essentially as a way to link our data to the elements that we're building. So if you sort of compare this to what we've been doing up here, it's kind of cumbersome to have to come up with a custom way to loop through everything. And with raw JavaScript, it's possible to sort of bring in bring in your data. If you're reading like a CSV, you'd have to sort of manually parse that. So that's part of what D3 does. But assuming you've already done that, you could sort of have your data and just sort of loop it manually like this. But D3 has its own sort of methods of doing this. A lot of which we were going through during our last meetup. So I won't focus too heavily on these, and I'll focus more heavily on sort of what we were doing, on the example that we have for the advanced part, which is bringing in some new concepts. But to just sort of review what is happening here, we're bringing in, we're just sort of reading in our data like so. We're sort of building these separate sort of bringing in and loading the data, and then we're actually making our table here. So this is very similar to what we were working with before, but we're doing this in sort of more D3 style. So sort of using these using these sort of append when we're sort of working our way down the nested elements, and then once we're linking to the data, using this using this strategy here of selecting the soon to be declared objects, linking it to the data, and using the enter function and appending different, sort of appending on top of on top of that. So basically, we're sort of adding. In this case, this is just the header, but so the data that we're actually using is this columns array here. So if I were to do something like, change that in columns and refresh this, you'll see that now gets put in the name there. But I ended up breaking this down here because I'm using the columns to sort of read the data in. So let's refresh that. And then we have what we were used to there. So, just using the header, like this is sort of a common trick with D3 is, if you are working with more complex data and you need to do things like adding, access titles for your columns or something, you may need to, sort of reference those columns rather than the data itself, like what we're doing here. And, so basically with this rows, so first we're sort of building our headers. We're sort of appending our rows here. And then we're using sort of the callback function within data to essentially sort of reiterate through each cell. We're sort of looking at the cells. We're selecting all TDs, and what this columns.map is doing is just simply flattening our data. So we when we console log the data, we end up with something like this. And in order to flatten it, flattening it would essentially mean, like as we're sort of populating the cells one by one, you sort of have your, we're essentially iterating through each of these values here, which is what this callback function within data is doing here. Actually, if we were should be able to just do that, and so that we could see what this looks like in the. So yeah, this is just sort of reorienting what the data is going to look like, so that we could use it. So it's not like, as I've mentioned before, using tools like JavaScript. It's pretty low level. There's not it's not going to be sort of what like similar to what you have access to in R or Python, which is why if you are using JavaScript for a lot of these things, I sort of recommend using sort of either like pre-processing your data and making sure that it's exactly the way that you need it, or perhaps getting creative with Flask and sort of relying on the Python end to do your data manipulation, and then sort of returning objects back to the JavaScript side. So that's what's happening with this part 3 here. And then lastly, for question 4, this is similarly to what we're doing here. It's sort of accessing the data, but in this case, it's requiring user interaction. So here, we're looking at the we're looking at a function that will return the president's height and weight upon being typed in. So if you do something like this, you'll see information will be provided below. And so how we're doing that, again, it's pretty low level what is happening. So we have, again, our div ID here. And we're bringing in, we're sort of bringing in our raw CSV data. And we're still iterating through our data here because really like that's how we're making this filter here. So we're for each row within the data, we're checking if the name is this value here. I actually forgot to mention that for question 3 or question 2 as well. But here, like we're accessing the document. We have pres info. That's the name of the form here. Pres name. That's the name of the input, the text input box here. Dot value, and that is simply returning whatever is in the input box. So we're accessing that information. We're checking each row of the data to see if the president's name is equal to what is in the input box there. If it is, we're declaring this through selected output and using that same write to DOM helper function. So we're we're sort of we're accessing this right here and just writing the output that we're expecting here. So any questions on parts 1 and or 2 before we move on to a few more examples? Cool. So part 3, I left pretty open-ended. It was meant to build on top of module 4.5, where you were building an API to sort of, an API wrapper in this case, to sit on top of the existing Socrata API. And what we are looking at is, let's get in here, open this up. So this, what I ended up doing here, I sort of used, like this is very similar to what we were looking at 2 weeks ago and in the examples that were posted to the course GitHub page. So it's very similar to what we were, similar in structure to what we were looking at here. So we have sort of our main Flask app. We have, in this case, we have an API. We have our, sort of template being returned to the root. We are serving up anything in assets. So that's how we're linking the JavaScript to the index.html. So you can see where we are bringing in our script here. So very similar in form to what we were doing last time. One change is here you'll notice when we were building the API last time, we were sort of referring to the, and I forget the exact syntax, but it basically, you enter the type here and you would have, your variable being entered into the function like this. And we're not doing that with, we're not doing that this time. What we're doing instead is what we're doing instead is we're just having this bare trees API, and we're using these here, this request.args.get, and you could see in the comments what's happening here. So URLs are expected to be, sort of looking at the API and then adding these what are called queries. If you, these should look pretty familiar. They're pretty commonly used. You'll see that pretty much any place you go on the internet. And we're sort of using this to bring in our, in this case, latitude and longitude. But to show what I'm using that for, so let's look at the app now. And so it kept this pretty bare bones, but I wanted to show off a few things. First, I wanted to show off that when you are using JavaScript, like the con of using these tools is they're very low level, but the pro is you're able to very easily mix and match different like packages. So in this case, Plotly does have a Mapbox trace type. So I could have just used two Plotly objects for this, but just to sort of show what I'm, sort of show how powerful, using these lower level tools is, I sort of wanted to combine Mapbox with Plotly. And also this gives us access to more information. So what I designed this app to do is, I didn't include any text explaining any of this, but just in an unstyled way, what this is meant to do is allow users to interact with the map, in particular to click on various areas within New York City, and return information about the trees that are sort of within the general vicinity of where I've clicked. So as we're looking in Manhattan, you could sort of see different distributions of these trees. Manhattan has a lot of honey locusts. The Bronx has a lot of London plane trees, etc. Honey locust, I guess, is a more city-oriented tree. So something like this, I wanted to sort of highlight a few things. First, the mixing and matching, but secondly, I also wanted to show off that when you are using to just sort of re-highlight the concept of cross-filtering. So in our examples previously, we were really focusing on sort of users using web controls, and user makes a selection from a dropdown, from an input box, from a range slider, and that input is then leads to some sort of output. So when we were looking at the first two parts, you enter in a president's name that's meant for user input. You're using sort of a widget. You're using an element like that, and then you and then you're sort of changing content based on what you do there. So so basically cross-filtering is, rather than using elements like that, you're using the visualizations themselves to serve as your input. And a lot of times, like, this is pretty, you could almost think of this in terms of concepts like, almost joining tables or filtering. A lot of times you'll hear things like, the concept of drilling down. Here, like, this is sort of what's commonly referred to as drilling down, no pun intended, since this is looking at natural gas wells. But it's, you're looking at these wells, you're using that to filter further information on those wells. So in this case, your, you could sort of think of this in terms of a join where you have your oil production information over time that is keyed by, or in this case, it wouldn't be keyed because it's not unique for each row in the production, but you would, sort of have your you would have your wells being related in both of those tables, and you're using one to filter the other. So in this case, you're hovering over these wells and getting the production function based off of that. And this is serving as an example that, and this is possible using Shiny Dash or JavaScript, whichever mode you choose. Because you're writing the callback functions, or in Shiny's case, defining your server object and sort of mapping out how all of your callbacks are working together, you are able to, do more complex things. Like something like this, we have the raw data coming in, but, we're sort of making a softer query. We're just querying based off of like a range around where a user is clicking. So, that's just something to keep in mind, that you are able to, really, sort of add whatever you want in terms of these interactions. So let's go over how this is being done. And so we have our same, layout that we had before. We have our index.js where we where we have our JavaScript. We're bringing in that index.js over here. We have the, and then we have our API, which is essentially how we're offloading the creation of the secondary graphs. So, as we were talking about before, if we were trying to do all that in JavaScript, you would have to do it in a pretty low-level way. But here, I'm able to bring it into Pandas and do whatever I need to in Pandas. So once I bring these in, and I have this diff, and I'll show you what I'm doing with that diff in a bit. But I build my my URL here. So, and I didn't go into sort of all of the custom SOQL functions, but there's this, like you're able to use what they call the between function to sort of get ranges between two values. And I'm just simply using a sort of degree difference to sort of pick where I'm querying. So I'm basically, like, in the table, there are latitudes and longitudes, and I'm just querying, whenever latitudes or longitudes are between, whatever is decided with this diff. And it's not perfect. There are more, there are better ways to query geographically in this way. You could sort of draw, something like, sort of right off the bat, like what this is giving us is roughly a square, and you may want to include a circle or something like that. And there are sort of more ways of dealing with that, but I don't want to get sort of too bogged down in that. We'll just work off of this difference in degrees. And then we're building our Plotly object. And similarly to what we were showing off last week, 2 weeks ago, the figure is being built in the way that it would be built with JavaScript. So I'm not using graph objects in this case. I'm including this here, like type bar, which you normally don't have to show. And it's it's and with Python, Plotly Python versus Plotly JavaScript, it's pretty one-to-one, because you're just simply using like JSON to dictionary. So that's pretty much what JSONify is doing here. And so there's not much that changes between Python and JavaScript when you're using Plotly, but that's just one thing to keep in mind. So basically, I'm using Python to return a ready-made Plotly figure object to my to my client side, so to my index.js. So I'm using, and this is like these are actually the quote that's I don't even know what the quote is called, but the sort of what's normally on top of the letter N, sort of the accent mark. This is sort of how string templating works in JavaScript, but I'm basically sort of bringing in the variables directly and sort of building my URL in this way. So you can see I sort of have my trees API. I have my my sort of variables that are being put in, and I'm accessing those variables with these over here. So that's where I'm building that, and then to go through what's happening with Mapbox, and I'll also just point out the Mapbox documentation. I personally find their examples pretty useful, but the their documentation is pretty good for anyone who's doing more mapping for their final projects. I purposefully didn't spend too much time looking at mapping tools because there's just so much there. But like something like this is definitely well documented and a good tool to use for what you're building there. So each time you display your map, you have to include this map.onLoad. So you're defining your map as a variable, putting it in a certain container. In this case, we're putting it in the map container. And you're defining your zoom and center in this way, and then I have this second callback here where I'm referencing click events. So all I'm doing is registering any clicks on the map, and you can see I'm console logging what comes out. So let's see what we do have there. So I'm going into inspect here, and I did a few clicks. So this is what the object looks like as we're clicking on this. So it includes information about what's happening with that click, but the most important is just the latitude and longitude, which is what we're using to create these graphs. So we have our latitude and longitude coming in. We're referencing those over here. So this e dot e dot long lat dot either lat or long, and sort of adding that to our trees API. So we're doing that using d3.json to read in the resulting JSON, and because we already did all of the hard work in Python, we're just feeding that right to Plotly Plotly.react. So when we are feeding it there, React it either creates a new plot if there's nothing there, or it'll do what's called a restyle, which means it's just a more efficient way of changing the trace content in a Plotly visualization. So you have that happening, and that's basically the this app here, and so right now I'm using the Mapbox map as a, sort of as the input, but I could, there are also ways of using Plotly in that way. So one place that I would point you guys is, this is the JavaScript help page, and then on the left-hand side here, there's sort of a link to the Plotly.js events. And Plotly has its own event handlers here, or its own types of events. So you can see it's very similar to what we're working on with the map. You pretty much just use this .on terminology, and in this case, it's the event is a Plotly click, and you're sort of displaying information in that way. So here, this is just sending an alert. And this sort of shows what sort of information gets returned with these events. So you have click events, and you also have, you can get pretty fine-tuned with the sorts of events that you have. I don't know why this isn't doing anything, but there it is, yeah. So it just turns it back to, here we go. So, so I would look through these for the sort of, different types of events you're able to use with Plotly. And if you guys are using, JavaScript and using one of these, sort of visualization packages to use do your final project, most of these visualization packages, so you saw it with Mapbox, you'll see it with Plotly, pretty much with everything else out there, there's some form of, the ability to sort of log these events and, and sort of gather the information, from them. So I would look at that. And then for those who are using Dash, Dash itself, you're able to do all of this without, it's the same things under the hood, but using Dash, you're able to, and here this is just the main Dash page, and going to interactive graphing, you're able to do very similar things. So in this demo here, you could see different things being hovered over, clicked, being selected, etc. Something like that. We have selected data. So that's pretty much it I had for this meetup. I wanted to keep things pretty light since this is pretty much the last thing standing before a long Thanksgiving weekend. So everyone should have, just in terms of some housekeeping, everyone should have gotten back their final project proposals. So just one more time, if anyone else has any questions on that, we could talk about that with the last few minutes of the meetup. Cool. So everyone should have like some sort of instructions for what to do for assignment 6. Assignment 6 is also meant to be very open-ended. It's just simply using essentially creating like the initial visualizations that will be used for your final project. So for a lot of people, if I noticed potential pitfalls or potential issues that need to be fleshed out a bit more, I explicitly sort of mentioned that and sort of guided you to address those issues during during this assignment 6, just so that we have sort of that one more touch point before the final projects are due. And assignment 6 will be the last assignment, and then after that we just have the final projects. The next meetup, we have 2 more meetups. Next meetup, we will, I have some content just about, sort of surveying some more advanced libraries, should you want to sort of continue going down the JavaScript rabbit hole. And then that'll be our last meetup, and that'll be the second to last meetup. And then the last meetup is going to be when everyone is presenting their final projects. So that should be, I believe I set the project to be due that Friday. So I'm pretty much expecting completed final projects for that meetup, even though the project's not technically due until the end of the course. And sort of what I'm hoping for is that we use the meetup day to just sort of receive feedback and then incorporate that feedback with the last 2 days. So so that's pretty much a rundown of the rest of the course. So any other questions before we head off? Cool. So again, thank you everyone for coming in so close to the Thanksgiving weekend, and I hope everyone has a happy Thanksgiving. If you're in the U.S. and if you're out of the U.S., I hope you enjoy the lull in the next couple of days.
Thank you. Bye.
All right. Have a good night.